Hi there, this is Dr. Ramey. I'm going to go over a few practice problems on how to determine the minimal inhibitory concentration and the minimal bactericidal concentration. Here's the practice problem number one. A MIC assay shown here. Tube A contains penicillin G at a concentration of 0.6 mg per mil. The serial dilutions performed as shown. Then S. pyogenes was inoculated into each tube. The tubes were then incubated for 24 hours, and after 24 hours, growth was observed only in tube F. So from this information, can we determine which tube contains the MIC, what the MIC is, and what the MBC is? So in tube A, we know the starting concentration, which is 0.6 mg per mil. To answer the question, what tube contains MIC? It's the first, the concentration, the tube that contains the lowest concentration where there was no growth, and that is here in tube E. So tube E contains the minimal inhibitory concentration. So now we got to figure out what is it? What is the MIC? So to do that, we have to figure out what the total dilution factor is from tube A to tube E. So from tube A to B, it's a 1 in 10 dilution, so this is 10 to the minus 1. From tube B to tube C, it's also 1 in 10, so that's a 10 to the minus 1 dilution. Also 10 to the minus 1 from tube C to D. And then, of course, attention to detail. From tube D to E, it's 0.9 mil inoculum into 9.9 mil diluent, so that is a 1 in 100, so that's a 10 to the minus 2. So the total dilution factor into tube E is 1, 2, 3, 4, 5, so a 10 to the minus 5 dilution there. So to determine what the concentration in tube E is, we multiply the original concentration in tube A by the dilution factor. So this would be, so the MIC, the original concentration in tube A is 0.6 mg per mil. So this is going to be 0.6 times 10 to the negative 5 mg per mil. And we can convert that into micrograms per mil by, we know that there's 1,000 micrograms in 1 milligram. So if we divide this or multiply this by 1,000, that gives us 0.6 times 10 to the negative 2 micrograms per mil. And then we can adjust that for proper scientific notation by moving the decimal here. So that would make it 6.0 times 10 to the negative 3 micrograms per mil. So if the answer needs to be in milligrams per mil, then this is the correct answer. If the answer needs to be in micrograms per mil, then this is the correct answer. And what we really should do, instead of saying 0.6 times 10 to the minus 5 mg per mil, we need to make one adjustment here actually, to make this 6.0 times 10 to the negative 6 mg per mil. So actually this is the answer in the correct scientific notation rather than 0.6. But all three of these are the same answer, just adjusted for proper scientific notation, and then milligrams per mil versus micrograms per mil. And then finally, the question here, what is the MBC? Well, with only the data given here, we cannot determine what the minimal bactericidal concentration is. We need more information, we need more data. So given only this information, we can't determine MBC. All right, I have another practice problem to take a look at. What I think you should do is pause the video here and try to solve this problem on your own without watching the video first or watching the rest of the video. So pause, take a shot at it. When you think you've got the answers to A, B, and C, then resume the video and I will go through the solving for A, B, and C. Okay, so let's see how you did. So the original concentration here in tube A is 4 milligrams per mil. There's a serial dilution here. Looking at what tube contains MIC, well, tube D has the lowest concentration where there's no growth. So that is going to be our MIC tube, and we need to figure out what that concentration is. And then kind of looking ahead, what tube contains the MBC? Well, if we look at these data here, this is what we need to determine what tube contains the minimal bactericidal concentration. And we can see that the sample from tube B here did not cause any growth on the plate, whereas there was growth on the plate from tubes C and D. So tube B here contains the MBC. So let's focus on MIC first. We need to determine what the total dilution factor is here in tube number D. So 1 in 10 from A to B, that's 10 to the minus 1. 1 in 10 from B to C, that's also 10 to the minus 1. And then 0.9 and 9.9, that's a 1 to 100, and that's a 10 to the minus 2. So the total dilution factor in tube D is 1, 2, 3, 4, 10 to the minus 4. And so looking at what is the MIC, it would be 4 times 10 to the minus 4 mgs per mil. So if we're going to leave it in mgs per mil, we would just make sure that we have it in proper scientific notation there. And if we wanted to convert that to micrograms per mil, we would multiply by 10 to the 3, and that would give us 4.0 times 10 to the minus 1 micrograms per mil. And it would be okay if you left it like that, but you could also just put it like this in this case, 0.4 micrograms per mil. So if I ask for the answer in mgs per mil, then this would be a completely correct answer. And if I ask for the answer in micrograms per mil, then either one of these would work just fine. And now let's take a look at C here. What is the MBC? Well, we have enough data to determine MBC, and really we do it the same way, looking at the total dilution factor in the MBC tube is only 10 to the minus 1, right? So this would be 4.0 times 10 to the minus 1 milligrams per mil. We could just write it like that if we wanted to. And if I asked you to convert this to micrograms per mil, or ask for the answer in micrograms per mil, then you could put it in, you could make it look like this. It'd be 4.0 times 10 to the 2 micrograms per mil, or you could just put it as 400 micrograms per mil. Okay, so these would be the answers in mgs per mil and micrograms per mil for the MBC.